Until now, we've been using variables as our main way to store information in our programs. The basic idea of a variable is that we have some sort of a name that's associated with a type, and that gives us some place we can store information. For example, we've written things like, for example, int x, right? And then maybe we have equal 10, right? That's what our code would look like. And that would show us creating a variable that's meant to store an integer and then storing the number 10 into it. That's what we've been doing up until now. And in the last chapter, we also extended kind of what we had with Java's primitive types, int, float, char, and so on, with objects. So after that point, we were actually able to create variables that contain our custom classes. However, there's kind of a key limitation. Variables only store one thing at a time. Every time I need to have a new piece of information, I need to create a new variable. And unfortunately, that can get a little bit unwieldy. So let's take a look at when that would be a huge issue. Let's say you're in charge of writing a program to track what P.O. boxes in a post office are available or which ones have been rented. Imagine this post office in front of you, right? We have all these boxes, right? Maybe we have, box from 1 to 999. And so what we need to do is we need to write a program that essentially stores information or stores a boolean for each of these boxes, right? We want to know is each of them is it currently being used or not, right? So we're gonna have to have a boolean, true or false, that tells us that. And based on what we know so far, what would end up happening is that we'd have to create a variable for each of these, right? Each of these, potentially 999 boxes. So imagine, just with what we know so far, we go and we try to do that. Well, then our code is going to start looking like this: Boolean box 0, Boolean box 1, Boolean box 2, 3, 4, 5, and so on and so forth, right? And this goes on for many hundreds of lines until we get to the very end, right, with our Boolean box 999. So if we had our PO box tracking system set up to just use variables, this is what our code would end up looking like. We would need to declare these variables for every single box. And maybe, maybe I don't need 999 boxes, right? Maybe there's only, 750 or something like that. But the point is, I have this sort of repetition going on, right? I have to create a bunch of variables, and really they're not very different, right? They all have the same type, and then they all have this kind of number at the end of them, right? That's what makes them different, right? I have box 0, box 1. That's the only really difference there, right? It would be nice instead of doing this, right, if I had some way to create a variable that had different compartments in there, right? In the same way that this row of PO boxes has different compartments, right? We have these little boxes, and all these boxes are really the same, right? But there's a number on them that tells you, oh, this is, what number it is, right? Who owns that particular number, right? There's going to be an owner for each of these. That's nice, right? To have these little identical compartments. But when we went to go and implement it in code based on what we knew so far, we end up creating these kind of different variables. We don't want that. We want something closer to this idea of the PO box, right? We have kind of a bunch of things that are all the same, right? They're all the same type in our case, but they have some sort of a number or an ID associated with them. Or later we're going to use the term index. And what we can do is use something called an array. And this is kind of jumping ahead a bit. We are going to spend the whole chapter talking about this. But basically, all this code on my left, it's going to be replaced by one line. Boolean bracket 999 close bracket boxes. So what we're going to introduce is this new way to create variables. Here we're creating one called boxes this time. And instead of just storing one thing, instead of just storing a single boolean, it's actually going to store 999 booleans, right? So I'm going to essentially picture I'm building out an entire section of PO boxes, right? A bunch of different boxes. They all store the same thing, but they have kind of a different ID, right? A different index, right? Before I move ahead to the rest of the Java code, let me actually draw a little bit here. What we had in the past were separate variables. Separate variables, maybe I could draw them like this, just a box, right? Someplace in memory, I'm going to be storing that information, right? So somewhere, I don't know where, but somewhere. And there'll be boxes for each of these. I may not bother drawing them all in. And each of these boxes are really, they're the same. And then inside, right, I have some data stored, right? For example, maybe this first box, maybe that one's rented. The second one's rented as well. The third one is rented too. But then it's the fourth box, right? It hasn't been rented yet. So this is maybe the way I could represent my initial way of solving this problem, right? Having individual variables. Right? I have all these different boxes, and they could be somewhere off in system memory. But if I were to go and start drawing this picture in terms of this new idea we're going to be using, it actually looks more like this. I have essentially one big box that's been divided up, right? So I have these different little parts, these different little slots. And into those slots is where my data is going to be stored. So over here, right, my box 0, right, in this diagram corresponds to this first thing, box 1 to this one, box 2 to this, box 3 to this. But then over here, right, my box's variable, this corresponds to this entire thing. And then there's going to be actually this little number, this little ID associated with each of these compartments in this box's variable, right, this box's array variable. Right, so in this case, there's going to be actually a little number next to these that say, oh, that's at position 0 or compartment 0. This one's at position 1 or compartment 1, and so on and so forth. Right, so this is at 2, this is at 3, and maybe we have the rest of them. Right, really we should be going up to 999 in this picture, but I don't really want to draw all those out for you guys because we're just going to be here for a long time if I try to do that. So these potentially go on for a very long time. All right, we won't draw on the whole thing. But again, the idea is we have kind of these different compartments, all with a number on them, right? And so that lets us kind of store information for stuff in our program that's more regular, right? It has this pattern to it, right? That's what these boxes have. They all look the same. We just need to keep track of, is each one rented or not, right? They all, other than that, right? They all look the same, right? We want to treat them the same. So this is a way we can do that. Let's go over to the Lewis slides. The way they define arrays in the textbook is as an ordered list of values, right? Think of those compartments we talked about a minute ago. They were in some sort of order, right? Box 1 comes after box 0. Box 2 comes after box 1. When they say the word list here, really what they just mean is, oh, I have a bunch of things all together, right? If you've used other programming languages, list kind of has a more specific meaning. But here, just think of it as a group of similar things. So every single array we built has a name, right? This is what we had on the previous slide as boxes, right? Here they're doing an example of an array, right, that's going to keep track of scores from some sort of game, right? And so their variable is called scores here. And then inside what they have is they have these 10 slots, right? And so in the last slide I was drawing them vertically. Here they have them drawn horizontally. But these are their 10 little spaces, right? And each of these is going to store an integer. So this array here, right, this scores array, the thing it stores is going to be integers. So let me actually add that in here just so we can kind of have a complete picture, right? So this is int scores really is happening over here. And inside, right, I have 10 different compartments. And just like on the previous slide, each of these has its own kind of ID or index associated with it. Index is going to be the technical term we use. So the first thing is stored at index 0, which is 79 here. The second thing is stored at index 1, which is 87 here. The third thing is stored at index 94. And so on, right? So each of these numbers comes one after another, right? We said before, right, that they're going to be ordered, right? There's some sort of order to these indices on these different things inside of our array. One thing to be careful about here is that our indices in our array, our different compartments, they start at index 0, right? So over here, this first item is being stored at index 0. It's not being stored at index 1. It's being stored at index 0. And this is kind of a programmer thing. We like starting our arrays at index 0, right? Not at 1, right? Which is maybe what people think of when they're counting up, but just to start at 0. There are a couple of programming languages that start with 1, but in general, all languages will use 0 as the index of the first element in an array. To build on that, this array that they've created here has 10 elements in it. If I have 10 elements in it, but my first one's at 0, what that actually means is that those indices go from 0 to 9, right? They go from 0 to 1 less than the size of my array, right? So that's the rule here, right? The indices that are available to me are from 0 to n minus 1, right? N being the total number of elements in that array. I think I've been using the word elements here and not really explained what it is. So elements, really what that means is these little compartments here, right? This is an element over here. This is another element over here, and another element, right? So those are just little pieces inside of our array, our little compartments. Given that we have kind of an idea of how arrays are used to represent kind of multiple pieces of information and how they're all indexed, the question is, how do we actually use that, right? How do we actually get information into or out of an array variable? Well, it's actually pretty simple. And it's simple because Java, and indeed most programming languages, have built-in notation to do exactly that. Or I should say, to do specifically that. In Java, that's going to be brackets, square brackets. So let's say I had my scores variable, and I want to reach inside and read the data from the third slot, right? Over here, this would be the 94, right? That's my third piece of information. Let's say I want to read that. Well, if I want to do that, I would write this here in my program. Scores, open square bracket, the number 2, close square bracket. What this bit of code is saying is go to the scores variable array and look at the element at index 2. Well, since our indices all start at 0, index 2 is really going to be the third thing in that array, right? It's going to be the third element that I stored into it. So in this case, it's going to be that 94. If I written out something different, for example, let's say scores of, I don't know, let's go 4. Scores of 4, this is going to talk about a different element in that array, right? So instead of it talking about the third one, which is what this did, this over here is talking about the fifth one. So looking back on our previous slide, well, the fifth one, right, which is at index 4, is this over here, right? So it's going to be the 67, right? That would be our new element, right, if we were to write this slightly different. So basically, right, whatever index we want to look at, right, we want to go in and see whatever element is there, we put that number, right, that number of that index in between those brackets, right, and that will bring us to that position in that array variable, right? Because if I just say the word scores, that really doesn't mean much, right? Because there's all these different pieces of information, all these different compartments in the scores variable. So I always need to use my brackets to look at a specific index, right? To get a specific value out of it. For all intents and purposes, this little notation here, right? Scores, bracket, close bracket, will work just like the variable names we've seen elsewhere in Java. So in the past, we would have had something like, let's say, let's go int x here, kind of our standby. Anytime, any place in my program I could write x, I can write scores bracket 2 bracket, right? So this notation here, right, this large circle here, that can be used anywhere in your program that a variable can be used. So that means I can use it to read, right? So I can do, system.out.println of scores of 2, right, to display information out of it, right? The exact same, it's the same syntax, right, as using the x, right, using the standalone variable. As long as I have my scores with the brackets, it'll work exactly the same as that x by itself. And besides displaying it, I can also store into it, right? So I can also write scores of 2 equal, 10 or something, right? So I can put that on the left side of my equal symbol, right? If I want to store information into it. Overall, this notation, we use it any place we could use a normal variable. The main difference being, we have these brackets to let Java know which specific element or which specific index in the array we want to actually work with. Over here is a slightly more fancy picture of how you might draw an array. I remember that I also had this kind of vertical notation going on when we talked about the PO boxes. So here, right, the idea is, I have these different slots, and then there's an index associated with each of them. For this example here, they actually have this variable called height, so this is a little bit different, right? So here we can see that there's all these different slots, and these are all numbers, right, that look roughly like an average height. Right, and each slot is storing a different value. Right here, this one has, well, actually, think for a second. How many slots are in this array? So this here is an array that has 11 slots in it. And you can tell because it's going to be one more than the index of the last element in that array. Here are a couple more examples of the notation for arrays. So over here, right, we have an assignment. So this is our scores from before, and here we're storing the number 89 into the third element in scores, right? The element at index 2, right? We're just storing into it. We're storing into it because this thing over here, right? This scores part, scores of 2, that's over on the left-hand side, right? So that means we're assigning that value into that. We could also do some other things, right? So we could also have that index into scores not be a number, right? So this first example, we just had the number 2, right? We had a constant value. But what you can actually have is another variable that stores a number, right? For example, you could have a variable called first, and its type is int, and into that there's going to be some number stored. Well, what you can do, which is kind of neat, is use that as an index into your array, right? So that's what we have over here. We're using scores again, but instead of giving it a constant, right, giving it the number 2, we're actually pointing at the variable called first. The variable called first is really an integer, and it's storing some number that will be used as the index of the element into scores, right? And then that element, right, that's what we're going to assign into here. That's actually this entire line here, right? If you read out this line, what's happening, right, is that first we're going to scores, right, at index first. We're reading the value, right, because it's on the right-hand side. We're reading out the value, adding 2 to it. Increase a little bit, and then store it back into scores, right, at the place we took it out, right? So this whole line, right, is just incrementing or increasing, right, the value that's stored at index first in the scores array. It's just increasing it by 2, right? Takes it out, increases it, stores it back. This third line here is a little bit more complicated yet again. So here, right, we're calculating something called mean, right? So we're going to take the mean of integers, right? And there's only going to be 2 here that we're going to be averaging together, right? So here, right, our mean is going to be equal to scores of 0 plus scores of 1, right? So we're going to read out the first element here, read out the second element here, right? And then we'll take the sum of them and then divide them by 2, which is what I need to do in order to calculate the mean. The last example here, right, is just kind of the another expression. So here we can see we're printing out the values inside of scores. So here, right, you did the same thing as we do for any other normal variable. We've just written that, oh, hey, print out scores bracket 5 bracket, right? So scores of 5, right? So just print it out. It's just acting exactly like a normal variable, right? If we wanted to print it out. So that's kind of the main thing I had mentioned a minute ago, right? Is that this scores thing, right? As long as you do scores in your brackets, you can put this bit, right? Once you have that in, anywhere you could put a variable that's kind of a normal variable, right? That only has one thing stored into it. This, put it anywhere you want.